All right, my friends, let's play with some macro data, looking specifically at the labor market. Sample stats you are. So we're going to be looking at the unemployment rate. I want you to gather it. I want you to compute some rates of change. I want you to use some fancy Excel tools to adjust for vagaries of the data. I want you to compute sample stats, z-stats, histograms, and maybe even make a plot or two. All right, so first thing that we got to do is go and grab the unemployment rate. That's the UN rate. Put it in A1. Fred needs it there. LIN, no transformation. BLS collects this data and reports it on a monthly basis. You can leave A4 blank. First date happens to be 1/1/1948. If you leave it blank and you go to data, Fred, get data, it will populate it for you. So you'll have a sheet come out that looks something like this. Yours may not be blue automatically. Now, in the skeleton I provided to my students, that is blue. Where do you get this whole alternating blue, white, blue, white? It's a table. So you go over here and you click on it and you see whoop, table design pop up. That means that it is a table. It happens to be called UR table. All right, now we want to compute rates of change in column C as the instructions say. You know how to compute a rate of change, right? So let's say you did this. Equals, and watch my cursor, watch my cursor. You want to do this one, B9. Click on it. I clicked on B9 and it shows brackets at value bracket. I didn't type that. Since it's a table, Excel is referencing that row and that column of the table with the at value symbol. If you referenced a different column, it would reference that column name, the same table, which is a UR table. All right, so let's take a peek. Now, when it references the cell prior to that row, it doesn't call it by the table name, but it uses it in the same way. And you can do that same formula for all of those. And you could even put it into the first one. Now, you notice it says at value. Something's wrong. Why is something wrong? When you double click on that, you notice in Excel, it highlights the particular cells that it's referencing in that formula. One of them is 3.4, cell B8. The other is B7, which is just written words, text, value. You can't compute a percentage change over that. So what you could do is just start your formula over here in C9. That's easy, but we want to be able to automate this. I want you to be flexible, so I want to show you another tool. What if in column D, you could set something up with the logic of Excel so that you can compute that percentage change, but you could also eliminate those areas where there's trouble. That's where this fancy formula comes in. I'm going to see if I could make this bigger for you. All right. So take a look. I don't know why I'm pausing. You can pause the video. If or is number false, is number false, parentheses, and then some division. It's a mess. The way I recommend you trying to interpret these long formulas in Excel is start at the kernel. If it's an if statement, then the kernel is all the way at the end. If this, then do that. So what are we doing? At value divided by B8, 8. That's what we had before. This is trying to construct a percentage change. And in fact, when you look at column C and column D, they are going to give you the same answers, except when there's trouble. All right, so let's go back to the formula. So it's saying, look, compute this percentage change, but I want you to keep track of the issues that we discussed before. And if there is an issue, then I want you to just leave it blank. The way you put it blank is just two quotes, nothing in between, just two quotes. There's other ways you could do that. In some instances, you actually want an NA. So when you're doing plotting, for example, Excel can skip over those. But for now, we'll just do it this way. Okay, so how do I know when there's trouble? Lots of ways we could set this up. I wanted to illustrate the or and the is number commands. So for that, I want to reference the date column. Is number. Okay, so is it there? Is there a number inside of that particular cell. Don't forget, I am clicking on D9, row 9. So it's referencing row 9. When it says at date, it's the date column row 9. Is that a number? False. So that's not a number. So if that's not a number, then give me the empty quotes. Or if A8 is not a number, give me the quotes. So if either of those two dates is missing, if either of those two dates is not an actual date, is not a number associated with some numerical date, then what I want you to do is give me the quotes. Otherwise, go ahead and compute the percentage change. So once you get that logic, you can do that for all of these. And you do it here, and look at that. It's referencing, look, see where it's highlighted? It's referencing A7. Well, A7 is not a number, so that if or is number A7 equals false, all of a sudden that's triggered, right? Then it puts nothing there, air quotes. That's why it's nice and blank and neat. Again, there's other ways that you could do this. Let's take a look at one case. Let's delete, for example, that. Okay, so why did both of those go blank? Double click on this. See what it is connecting to. If is number at date. So in row 10, date column, if that's a number false. Okay, so it's not a number. Why is that? Because it's missing. Then you put air quotes. All right, what about this one? Why is this one missing? Okay, so if it's is number, we're in row 11. If the date column is not a number, then false. But hey, I got 4, 1, 9, 1, 9, 4, 8, so that's all good. But if is number A10, the one prior is missing, give false. So I'm gonna, I broke it. Hopefully I can put it back together. There we go. All right, so now we have a nice neat column. Again, there's many ways that you can do that, but that's one. What I want you to do now is summarize those rates of change. And we know how to do that with mean, that's the average, standard deviation, min, max, and count. Since we have a table, we can leverage the table functions. Just compute average under UR table. If you want to see that in action, average, right? Because I want to compute the mean. Okay, I remember my table, was it little case UR, big case? Just start typing it in. All right, so it was a capital T. You could hit tab. Okay, now, which row did I want? Was it capital V, lowercase v? Hit the bracket, and then all of the columns show up. So value right there. Hit the tab. Close the bracket, close the parentheses, and you are an Excel stats genius. You can do that for standard deviation. You could do that for min. Hey, look at that. That's weird. That is showing up hard code. So let's fix that on the fly. Should never fix it on the fly, but I live dangerously. Value 2.5. All right. Max, and then the count. The count A function will tell me how many of those observations are there in there. Next up, what I want you to do is give me the value associated with the min. How would you find that? So let's think about it. What I could do is, all right, so there's the values. I'm going to go in column B and just physically just scroll on down 5, 4, 3, 2, 9, no, 2, 8, 2, 7, 2, 6. It's not quite 2, 5. There's a 2, 5. There's a 2, 5. Okay, so I had to visually search. There's two values that are at that minimum level. Which one do I pick? Let's say they were numerically identical with rounding, etc. Excel is going to go for the top one on our way down. That's a pain in the ass. Like, how do I replicate that? Well, let me scooch over so you can see that. Index and match. I think the best way to understand index and match is if you break it up. Let's do this. Let's do match. Let's do the inside. Remember the idea, whenever you're working on these, work from the inside out. So match, what's the lookup value? I want to look up the value 2.5. Where do I want to look it up? In the UR table. Tab, bracket. Which column? I want to find the value of the UR table. And do I want an exact match, less than, greater than? I'm going to find an exact match. Okay, so in the UR table, I want to find row 65. I don't mean row number in the Excel spreadsheet. I mean within the table, it's the 65th entry. So what's the data associated with that? What I want to do is use index. I want to use the UR table, and I'm trying to get back the date. I already have the value, so date tab bracket. Now, what's the row number I want to call? Well, we just found that. That's 65. Oh boy, I wanted a date and it gave me this weird number. Wait a second. Short date. There we go. Worked. Okay, so that's the way index and match are going to work together. You can do that for the max or any of the others. Now, next up, I'm going to clear that. You want to replicate those sample stats for the delta 1 column. Remember that was this one over here. And when you do that, average UR table delta 1, the formula's right, but that didn't work. Well, the formula's right, but that didn't work. The formula's right, but that didn't work. What's wrong? You got that in there. You got something that's not a number inside of there. So there's many ways that you could deal with it. The way that we're dealing with it here is by leveraging the other column, the nice and neat column where it had the air quotes. So I'm referencing delta 2. All right, so we got the data, we got some sample stats. I want to create a histogram. So lots of ways you could use the data analysis tool pack. What we want to do here is use the count ifs function. How many bins do I want? J18 minus J19, so max minus min range. Round up 0 digits, so I'm just going to have integers times 2. So you look at the scaling of the unemployment rate. It's like 2, 3, 4, 5. I'm going to break it up into 2, 2.5, 3, 3.5. So double the number of those integers. You could have picked 0.25 increments or whatever you want. And the lower edge of that first bin, round down for the min. J17 is the min. So I'm going to go to 2.5 and round that down. So I'm capturing that one right there. So I want 26 bins starting at the number 2. Few ways you could do that. Here, I'm using the sequence function, but depending upon your version of Excel, if you're online or not, sometimes sequence function acts funky. So it's easy. What you can just do then is physically write in the number 2 and then put 2.5 and then drag that down. It will sequence that for you. The upper bound would just be adding on 0.5 to that. Sequence is going to say the number of rows. In this case, J24 is 26 rows. One column, because I just want that bin range. The number that is referring to where I'm starting, J25. We already calculated at 2, and I want 0.5, those increments we talked about. The upper bound works in a similar way, but I just added on the 0.5. Okay, the real heart of this is going to be the frequency. How do I count the number of rows in the table that are between 2 and 2.5? Count ifs. So count ifs allows you to do the logic where you could put things together. I want to count if the value from the UR table, that's the first chunk, is greater than or equal to I28. I28 is the lower bound. Now, you see where it's this quotes greater than, quotes, ampersand, I28. What that means is you need to tell Excel that the greater than sign is read as math, quotes. And you need to append that to I28, whatever is the number in that formula. The ampersand appends it to it. You want to do the same thing for UR table, the value. Less than or equal to, read it as math, ampersand append it to the upper bound. So there are 2 rows inside of that table that have unemployment rates between 2 and 2.5. The relative frequency, okay, so the count gives you the frequency. Relative is with respect to the total number. We already found the count, 928. So divide 2 by 928 and you get 0.2%. Relative frequency is a percent. Repeat that across all them. You know, you could put on a handy dandy fancy graph and you got the relative frequency histogram of the US unemployment rate going back to 1948. And what you see is there's a whole lot of skewness, right? Look at that right tail. Stuff goes way out there. These are the big bad boys of the COVID recession, etc. And by the way, this doesn't include the Great Depression. Our data here doesn't go back to that. Otherwise, it would be a whole lot further to the right. Almost done. Next thing I want you to do is compute a z-stat. Remember z-stats. It takes the observation, subtracts off the mean, divides by the standard deviation. We already computed the mean. We already computed the standard deviation. So this should be easy peasy. Take the value. So we're double clicking on E8. So it's taking the value of column B in row 8 minus J15. Make sure you lock that down with the dollar signs because I want to use that same mean value across all of them. Divide by J16, lock it down with dollar signs because you want to use that across all of them. You do that all the way down. Now, oh, I didn't update my data. That goes until April 2001. Click update FRED and you get more. Yours may not be colored. How do you make it colored? You can go ahead and you can Control Shift down arrow. You can highlight all that. Go to conditional formatting and then color scales, and you can make it nice and pretty, whatever formatting you want. The reason why that's helpful, is because you can get a sense of where things are different. And look at dark green, 5.34. What does that mean? 5 standard deviations away from the average. Okay, so go back, think about what that means. The average was 5.68. Standard deviations was 1.7. So it's 5 of those 1.7s added on to 5.68. That's a big unemployment rate. Let's go back on down. That should be at April 1, 2020. April 1, 2020. April 1, 2020. We went a long time without seeing anything like that. And then we got hit in the face. We had an unemployment rate of 14.8, April 1, 2020, exactly what our table found. 5.34 is huge. If you want to visualize that, you could take a look at a simple little chart of that z-score. And you can see COVID and how ridiculous that is. Now, if you charted out the regular unemployment rate, it would have the same pattern. The only difference would be the scaling. Right, the values would be percentage points rather than z-stat. Hope that helps.